Ladies and gentlemen, my name is Natalia Pydyn, and together with my colleague Marta Kościelniak, I would like to discuss the laboratory tests and analysis and their role in the conservation work of the movable historic objects in the museum collection. The conservation process begins with detailed laboratory analysis of an object to see the material and to recognize the stage of degradation. So the threat to materials are both physical and chemical threats. The laboratory of microbiological and genetic tests evaluates qualitatively and quantitatively the microbiological pollution of the surface of historic objects and the air in which they were kept. The studies are important because the deterioration of the materials building up historic objects that is carried out by microorganisms is a serious threat posed by those organisms. So, if there are conditions which are favorable for the development of microorganisms are persisting in the storage places. An important element of our work is guarantee the safety for the museum staff. That is why we try to eliminate the microorganism which might be harmful to people. The microbiological research begins with a smear, which can be collected from any surface. The objects in our collections could be the leather shoes or a piece of fabric. And then we have the culture and the bacterial strains, which are multiplied thanks to that culture, is studied in professional laboratory with mass spectrometry. We also perform macro and microscopic assessment. Apart from the classical microbiological methods, the identification of microorganisms is also made with molecular methods such as real-time PCR, which will help us to identify their DNA strands. And this has the objective to have the species identification of the fungi and bacteria, which will help us to select the most appropriate method of disinfection. In the case of finding microorganism on the object in the level that exceeds the admissible norms, or when they pose a serious threat to the object or to people, the object needs to be disinfected. The agent must be effective, but they must not alter the properties of the material. Also, they must be safe for the conservators. When it is necessary to disinfect an object, the laboratory staff, tried to find the most appropriate method and agent. Also, they carry out the scientific research to find the appropriate disinfection methods to tailor it to the needs of an object. For the object which require only point disinfection, we use the diode laser, which so far was used in dentistry for the removal of the bacteria, for the bacteria residing on the leather and on paper or cardboard. And we remove them only from infected places. So the use of optimum variation leads to almost 100% removal of microorganisms, does not alter the color, or does not infect the morphology of the surface. Our laboratory also has the disinfection with vaporized hydrogen superoxide, and this leads to the best parameters of disinfection and also has a biocidal effect. This is used for large objects by means of fogging the places with infected objects. Another method that was worked in the laboratory was the disinfection of historic objects with 90% ethanol, which is applied in a form of fog. The method can be used for all surfaces of objects, and its biocidal effectiveness is almost 100%. That is why it did not show any negative changes in morphology or structure. As part of our activity, we collaborate with a number of scientific and academic institutions in Poland for identification of the type of microorganisms, the study of the structure of an object, and testing the impact of new methods of disinfection on the object. Because of the interdisciplinary character of the works, finding the collaborators is really difficult. That is why we value so much the collaboration with the scientific institution that we list here in the slide. Some works carried out by our team will consist in optimization of the effective disinfection methods, which are also safe for people that work with such objects. The purchase of specialist devices will help us to identify microorganisms that live here, which will protect the objects against the microbiological pollution. Thank you very much for your attention, and over to my colleague. Ladies and gentlemen, good evening. In our physical and chemical laboratory, we carry out the research of qualitative and quantitative composition of material and secondary layer on the surfaces of historic objects. And for this purpose, we use such devices as XRF spectrometry, peer spectrometry, and spectroscope, and optical and digital microscopy. All the listed techniques complete one another and are used for the majority of the objects in the museum collections. Moreover, the laboratory has so-called climatic chamber, and this device allows us to carry out aging processes in controlled conditions, and also study the use of conservation materials, which helps us to assess the safety of such material. The FTR spectroscopy, the FTIR spectroscopy, which Fourier transformation, it is a non-destructive method which helps us to see the chemical composition of the studied material together with the protective layer, which is of vital importance for the effect of degradation method. This is a research method that uses the beam of light with the wavelength between 1.5 to 2 and to 2000 nanometers. So this means the medium red wavelength. So when it touches the sample, it leads to the trembling, which is illustrated in a form of a spectrum. And the spectrum is analyzed by means of correlation with the data libraries. And such spectrometer with the spectrum analysis is presented here. So we can see the result of such an analysis. The FTIR spectroscopy is used for the identification of organic compounds such as polymer layers, textiles, and other materials. The laboratory of the conservators uses it for the analysis of the brushes, suitcases, and shoes and other objects which are made of the organic materials. The spectroscopy, XRF spectroscopy, that is the Röntgen fluoroscopy, it is also a non-destructive method which helps us to analyze the elemental composition of an object. It measures the emission, the secondary X radiation, and the of a sample that is agitated by the radiation. The result of such an analysis makes up the spectrum, which shows us characteristic wavelengths, characteristic of specific elements up to the level of uranium. XRF spectrometry leads us to finding the contents of various elements in objects, especially in ceramic and construction materials, and also in archaeological objects. The museum collections have a number of objects which are applicable in this analytic technique.
A digital microscope, which we have in our laboratory, lets us carefully and meticulously observe the surface even in 1 to 1000 magnification. However, the best item is the additional head for analysis. That is so-called laser-induced spectroscopy, LIBS, and that's a method that makes use of laser impulses for identification of the elements in the material and is a complementary method to the XRF technique, as it has a broader spectra measurement and greater precision. The spot is about 10 nanometers, so the diameter of 10 nanometers allows analyzing microscopic samples of 10 nanometers. The optical microscope that we have is mostly used for working in various lights. UV, polarized light, lets us see those elements of construction which are invisible in the visible light. This microscope can also be used for observing changes that take place during microanalysis of textiles. Here we have on the left-hand side those fibers, and for microchemical analysis, mostly for identification of pigments and the successive layers of painting. In our laboratory, we also run uh, aging tests. So extreme conditions include high temperature, increased humidity, and UV radiation to speed up processes of aging, which would have taken years in normal conditions. This method gives you quickly information about the potential speed of degradation and efficiency of various conservation methods like use of new means of conservation and preparations. Physical chemical degradation in some objects in our museum call for a range of specialist tests and examinations that cannot be made on the spot, for which reason we often cooperate with various institutions throughout Poland. For example, Department of Chemistry of the Jagiellonian University and the Kraków Academy of Fine Arts, Chemistry and Physics in Conservation. We also try to share our knowledge at conferences related to the subject of chemistry in conservation. We also intend to purchase more equipment and extend the scope of analyses to speed up identification of the materials that we use, and also to study other coatings on those objects. Thank you very much for your attention. Good evening. Ewelina Sieradzka and Jan Kapłon. Closing this session, we wanted to tell you about one of the projects that we currently carry in our collection. It pertains to the conservation of the most touching objects from the collection, namely the children's shoes, what's left of the youngest victims. We have 8,000 of those in our collection, and they are part of a huge collection of the civilian shoes that after the war were found in two locations, in Canada 1 and Canada 2, and in Erweiterung buildings. That was an extension of the camp in direct vicinity of the mother camp. Photo on the left shows how those civilian shoes were found. In this form, they survived from the moment of establishment of a museum and the main exhibition, this is how those shoes they were presented to the visitors. This way of their presentation resulted in the decision to have them inventoried the way they were. All the civilian shoes are in the inventory as one mass object, 40 cubic meters of shoes. Obviously, it consists of individual items. However, this whole group is present here as one complex item, something which proves the mass nature or character of the crimes committed. While the camp was in operation, shoes were more and more often made accessible for various exhibitions in Poland and abroad as individual pieces. Due to the passing time, they had to be subjected to conservation practices, so small groups thereof were removed from the permanent exhibition. We more and more often found individual signs, inscriptions, all those tasks, conservation, historical research of individual items were connected to the establishment of appropriate documentation and making an appropriate inventory of those shoes, 40 cubic meters of those. That task was really not satisfactory, hence the decision to re-inventory them and to treat them as individual objects, separate, for quite a long time, really for years. For example, during conservation, temporary catalog numbers are assigned to the shoes. They are a kind of preparation to making an inventory for that group. Thanks to the support from International Auschwitz Foundation and the March of the Living, in August 2023, a conservation project could be started. Its task is to protect and to conserve this collection of children's shoes. However, as part of that project, we also carry preparation. That's a total database of individual objects. We create a descriptive database for all of them. We have completed about 2/3 of those, and these works, of course, are later conducted. This project should end in April 25, and by then we hope we will have a total database about each and every shoe. So this is going to be the foundation for inventory of this group. In detail about the individual stages of carrying out that project before those shoes go into conservation will be the subjects of Ewelina's talk. Apart from two of us, we have Sylwia Łukawska with us, and she makes photo documentation of the shoes. Good evening. Since April 2023, we have conducted a 2-year project, conservation of museum and archival materials in State Museum Auschwitz-Birkenau, conservation of children's shoes. That project includes works on verification of the number of children's shoes and we make a documentation that prepares them for conservation efforts. In the first stage of the project, the initial works included classification of those shoes, type, material, and they were also made ready for development of specific data cards based on individual temporary inventory numbers. The following step necessary for further work on it are measurements. Each shoe is precisely measured on specialist devices which register the weight, the sizes, and the volume of individual shoes. The data scanned from the device is input into a database and then used in the last stage, which is creating a data sheet. The following step in what we do is making a photo documentation according to a particular procedure. Photographs are taken on various planes showing four sides of the shoe and especially account for the characteristic elements. For example, a serial number on the internal part of the bootleg. Sometimes there are pressed signs on the soles and also labels showing the place of production. The photographs fully reflect the condition of the object before conservation, showing deformity of the skin, some seams where they were mended, different damages. Also, we can numerous mendings. Sometimes they are patched. There are elements in the soles, and sometimes just missing leather. Preserved among children's shoes are some that have more intensive colors, decorative patterns or cuts in the leather, or there are sometimes embroidered. Those are few. The remaining shoes of the victims are mostly badly damaged. They had seen years of wear and tear. Making the data or evidence sheets is food for the further development of specific catalog numbers with detailed information about each shoe that is described here. We account here for the color of a shoe, material, type. We also describe elements from which it consists and its individual features. For example, maker's marks, traces of mending, um, signs of wear, damage, missing bits of leather. And we also enter here the temporary inventory number, the measurements that had been made before, and a sample photo. Such a sheet is the last stage of work on each item. After this inventory is finished, the items are sent to the conservation lab where they are protected and conserved. Thanks to those steps, we can take the final decision which of the shoes, due to their condition, would be exhibitable and which require storage in cardboard boxes made of acid-free cardboard. You can see them here in this photo. They create optimum environment and provide resilience of the object to external factors. After completion of work at the permanent exhibition, around 2,000 of children's shoes returned. They have been conserved under the project. The current condition of this um, display is shown here. The planned deadline for the project is April 2025, and by then we intend to have all data on 8,000 children's shoes. Thank you. Thank you very much. I'd like to thank all the speakers for the presentations. They showed a broad spectrum of work that is conducted here. And ladies and gentlemen, when the last eyewitnesses and the survivors are passing away, we're trying to build our remembrance on what's left, accounts and objects related to Auschwitz. Here in the collection, every item is of great importance. That's where you find them. Here, those items are protected, conserved, and also exhibited at exhibitions so that you can watch them. Ladies and gentlemen, this session is approaching the end. I'd like to thank the speakers and you for connecting to us, for listening to those presentations, and I encourage you to participate in the future events. See you. Thank you.